Scientific notation, helping us write really tiny or really big numbers. Carelessness when using numbers. Here's some times when people really just go overboard with numbers. I have a million math problems. They're exaggerations. I have a trillion things that need to get done. If you win $1,000,000 and you're given the prize in $100 bills, your stack of money is 4 inches high. Not that much. However, if you win $1,000,000,000,000 and you're given the prize on $100 bills, your stack of money is going to be 67 million. 67 miles, sorry. Quite a bit more than the other amount. Scientific notation. There are parts to scientific notation. You have your coefficient, which must be a number from 1 to 9.9. You have an exponent, which is a power of 10. 3.4 times 10 to the 6th power is easier than writing 3,400,000. Numbers greater than 10. Find the number by moving the decimal point that is between 1 and 9.9. So we start here by moving our decimal point. Now, remember, think about large numbers like money. If you were thinking of this as $45 million, 45,300,000, then you know your decimal point will be at the end. But we have to get the decimal back, so our number becomes a number between 1 and 9.9. Now, when it's a very large number, your exponent is going to be positive. You're going to write a positive exponent equal to the number of places you move the decimal point to the left. This is not new. So our answer is 4.53 times 10 to the 7th. Numbers less than 1. Find the number by moving the decimal point that is between 1 and 9.9. This time we have to move the decimal in the opposite direction because our number is too small. Write a negative exponent, which is equal to the number of places you move the decimal point to the right. Again, review. So in this case, we moved our number 4 places to the right, 2.91 times 10 to the negative 4. Operations with exponents. We're talking about math operations. For multiplication is very simple. You multiply your coefficients and you add your exponents. This is something you need to write down because you don't have this in your notes now. And when we're doing our practice problems tomorrow, then you're going to need this information. 3 times 10 to the 4th power times 2 times 10 to the 2nd power. Well, we multiply our coefficients. 3 times 2 equals 6. And our exponents, 4 plus 2 equals 0. Oh, sorry. 4 plus 2 equals 6. So our answer is 6 times 10 to the 6th power. Sorry. For division, divide your coefficients and subtract your exponents. The opposite of multiplication. Makes sense. 6.4 times 10 to the 6th divided by 1.7 times 10 to the 2nd equals 3.8 times 10 to the 4th. Divide our coefficients. 6.4 divided by 1.7 equals 3.8. 6 minus 2 equals negative 4. Equals 4. Wow, doing really good on this one. Be careful. Remember the rule for coefficient. In this case, when I multiply 4 times 3, it gives me 12. When I add my exponents, I get 7. But we know with scientific notation, our number coefficient cannot be 12. So we have to move this decimal to get this number between 1 and 9.9. So you have to move that decimal 1 to the left and increase your exponent. 1.2 times 10 to the 8th. For addition and subtraction, you must make the exponents the same. Addition and subtraction are the hardest operations to do with scientific notation. In this case, we have 5.4 times 10 to the 3rd plus 6 times 10 to the 4th. It doesn't matter which one you change. You can move that 5 and make that 10 to the 4th. You can move the decimal by the 6 and make that 10 to the 3rd. It doesn't matter. In this case, they moved the decimal back by the 5. So now we have 0.54 plus 6.0. Those two, you add them together, it'll give you 6.54. When you're dealing with that, since your exponents are the same, then you don't have to do anything but bring that exponent down. So the biggest part of this is getting the exponents to be the same. Sometimes exponents are written differently. We are used to seeing 3.4 times 10 to the 5th. However, you may see 3.4 e to the 5th. And that e is replacing the exponent and replaces times 10. So represent the exponent and replaces times 10. So what that does is, on your calculator, this is normally where you're going to see this, on your graphing calculator, when you put in numbers with exponents very large, very small, it's going to give you e to the whatever power instead of giving you times 10 to that power. So you have to understand that the e is the same thing as times 10. We will go through some problems tomorrow in class. I just wanted you to have a basic understanding of how to solve these problems. We'll practice some tomorrow. You'll do some activities that's going along with that to get you used to that. There should be a couple of problems on here if you want to practice them as well. So just look at the next section of this blend space, and there should be some problems that you can practice. However, if you're not clear on how to do this, we will go through it again tomorrow in class.